Hello everyone, my name is Mr. Babruan Solunke, Assistant Professor, Department of Computer Science and Engineering, Walchand Institute of Technology, Solapur. Topic of this session is Scikit Learn. Learning objective. By the end of this session, student will be able to understand the feature of the Scikit Learn library and how to use Scikit Learn library for machine learning model building. Now what is Scikit Learn? Scikit Learn is the most useful and robust library used for machine learning in Python. It provides a selection of efficient tools for machine learning and statistical modeling, including the different algorithms, classification, regression, clustering, and dimensionality reduction via a consistent interface provided in Python. This library is largely written in Python and it is built upon the other libraries such as NumPy, CP, and Matplotlib. Origin of this Scikit-learn library. Originally it was called as Scikit.learn and was initially developed by David Cornopio as a Google Summer of the Code project in 2007. It is first public release is on 1st February 2010. Community and contributors. This Scikit-learn library is community effort and anyone can contribute to it. This project is hosted on this GitHub website. Various organizations like Booking.com, JP Morgan, Evernote, Inaria, Aweber, Spotify, and many more are using the Scikit-learn library. How to install this library? We have to use the pip installer using this command pip install Scikit-learn. After installations, we can make the use of this library. And what are the features provided in this library? That is most important. So rather than focusing on loading and manipulating the summarization of the data, Scikit-learn library is used for modeling the data. And some of the most popular groups of the models provided by the Scikit-learn library are as follows. Supervised learning algorithms. Almost all the popular supervised machine learning algorithms like linear regression, support vector machine, decision tree, etc. are the part of this Scikit-learn library in the form of the classes and the functions. Unsupervised learning algorithms. It also has all the popular unsupervised learning algorithms in the form of the built-in library classes and functions for clustering, factor analysis, principal component analysis, unsupervised neural network, etc. We can do the clustering task using this library for grouping the unlabeled data. We can do the cross validation to check the accuracy of the supervised machine learning model on the unseen data set. Dimensionality reduction. Dimensionality means features reduction. That it is used for reducing the number of attributes or features present in the data, which can be further used for summarization, visualization, and feature selection. Here we have the implementation of the classification model using the Scikit-learn library for classifying the iris dataset records. In the Scikit-learn library, we have the different inbuilt datasets like iris, digits, Boston house prices for regression, and so on. So many datasets are available. Here we have the example to load the iris dataset from the sklearn.datasets package, and by making a call to the constructor function load_iris of the load_iris class, we can load the iris dataset data. And this data will be divided into in the input x and the output y. Iris.data is a function. Data is here the inbuilt parameter. It is used to extract the data present in the iris dataset and assign it to the feature metric x. And the output y will contain the target values of the given datasets. Here we can see the feature names and the target names of this iris dataset by using the inbuilt feature names and target names. Here the feature names are sepal length, sepal width, petal width in centimeter, and the target names are the class label of the iris flowers, setosa, versicolor, and virginica. And here in the last print statement, we are printing the first 10 rows of this given data set for the input features, that is 5.1, 3.5, 1.4 and 0.2. These are the values in centimeter for the sepal length, petal length and petal width for the given data sets. To check the accuracy of the model, we split our dataset into training and testing part. Training part, it is used for training the model, and testing set, it is used to test the performance of the model. We can evaluate how well our model did. The given example will split the dataset into 70-30 ratio. 70% of the data will be used for training data, and 30% will be used for testing the performance of the model. Here we have to use the train underscore test underscore split class from the sklearn.model selection package. We have to import it, and by making a call to the constructor function of this class, we can split the input x into xtrain and xtest, and the output y into ytrain and ytest. And the splitting size for test is 0.3. It means 30% of the rows will be goes into the testing data set, and remaining 70% of the rows will be goes into the training data set, like such as xtrain and ytrain. And this splitting will be done in the random fashion, because we have set the random underscore state parameter equal to some integer value a1. And if we check the size of this xtrain, xtest, ytrain, ytest, you can see the output. Here in the data set we have total 150 records. Out of that, 105 records are goes into the training set, and 45 records are goes into the testing set. Think and write. Take a pause, give the answer. Which class in scikit-learn library is used for splitting the input data into training and testing set? Here the correct answer is C, train underscore test underscore split. Now after splitting the data set, we can create the KNN classifier model by making a call to the inbuilt class kneighbors classifier from the sklearn.neighbors package. And we can evaluate its performance by using the metrics from the sklearn library. Here we are creating the object of this KNN classifier by making a call to the constructor function kneighbor classifiers, and the number of neighbors, that is value of k, we have set equal to 3. Now we can train this classifier with the help of the fit function on the training dataset xtrain and ytrain. The KNN classifier will be get trained. It will learn the input output mapping between the xtrain and ytrain, and after that we can allow the model to give the prediction about the input dataset x underscore test, and the predicted output will be stored into the y underscore read variable. And then we can check the accuracy of this model by making the use of the accuracy underscore score matrix by passing it the two values, that is actual output y test and the predicted output y pred. And here you can see the accuracy is 98%. So model is performing well. 98% means it is very good accuracy. And here we can pass the any two sample of the iris flowers and get the prediction what is the class label for this two sample. And here you can see versicolor and virginica are the class label for these two samples containing the value 5532, and for second sample 2435. These are the references. Thank you.